The cosmic space, full of dangers and mysteries, is now even closer. NASA has discovered two black holes of a new, previously unexplored kind, and they're currently the closest to Earth. In the summer of 2022, the Gaia mission noticed some atypical fluctuations of stars in one of the sections of our very own Milky Way galaxy. Everything indicated that they were orbiting a large object, but there were no remnants of space object absorption, nor was there any radiation of light in the X-ray or radio range. Mathematical calculations made it possible to determine that the movement of stars indicates the existence of invisible and truly black holes. Gaia BH1 and Gaia BH2, both located quite literally in humanity's backyard, indicate that there are more systems of black holes than it was thought a few months ago. There might be a different story to their appearance, which is not yet known to either scientists or laymen like you and I. Let's go back to June 2022. The mission of the European Space Agency is publishing the third series of articles about the discoveries made using the Gaia telescope system, which has been actively functioning in orbit since 2014 to compile the latest knowledge base about our galaxy. Its main task is to create a global map of the stars of the Milky Way and to clarify the history of its origin and development. The collected data show astronomers how stars are born and how exactly they saturate space with matter when they die. A range of different equipment on the spacecraft allows scientists to study the trajectories of motion, speed, radiation of objects, and even their chemical composition. The telescope is located at a point of gravitational equilibrium in the orbit, which remains close to completely unchanged relative to the Earth and the Sun. This allows it to remain stable to a point that is not available in near-Earth orbit, and also the ability to thoroughly explore the space around it. In their very detailed and long report about Gaia 3, scientists announced that the system was functioning with even more precision than expected. It showed them starquakes and changes in the surface of space objects that were similar to earthquakes and tsunamis. It visualized asymmetric motion of stars relative to the galactic core, which deepened our understanding of its spiral structure. Gaia also collected data on more than 800,000 binary stars for the first time. The gathering process was based on three methods: astrometry, photometry, and spectroscopy. For the first time ever, the so-called DNA of stars in their history shown through the chemical composition was collected in such a large volume. The very fact that it's possible to see which celestial bodies consist of primary material and which were formed from matter after the collapse of their predecessors shows the history of the galaxy. What's interesting is that the closer an object is to the center of the spiral, the more metals accumulate in its composition in places of frequent birth and death of stars. Gaia shows different types of matter that came to us from other galaxies, and those different composition from their neighbors. The staff of the mission compare the galaxy to a delightful melting pot, where gases and metals are transformed into new stars. In the multistellar systems that make up the galaxy, 2, 3, or more objects move around one another. The ranges of distances, the difference in radiation frequencies, and changes in the radial velocity stop being obstacles to creating a complete picture when an astrometric device, a blue-red photometer, and a radial velocity spectrometer are working simultaneously on the ship. These tools complement one another very nicely. Astrometry, or the method of determining double stars by uneven movement in the sky, was key in discovering something truly amazing. Aside from discovering hundreds of new paired systems, scientists have also recorded atypical cases. ESA researcher Timo Prusty stated the following: "Gaia is a research mission. It explores the star sky filled with thousands of objects multiple times, which narrowly focused projects do not do. We can't wait for the scientific community to dive into our new data to learn much more about our galaxy than we can imagine." Expectations were more than justified. Gaia measures the exact positions of stars. When comparing the data, an atypical oscillation of a companion star orbiting an invisible object was detected. At first, scientists expected to find another star, the visibility of which was worse than that of its partner. Another reason for the fluctuation could be the presence of a satellite planet orbiting the star. and thereby affecting the trajectory of movement. The hypothesis of a black hole in the Milky Way seemed ghostly. Usually, the distance between these objects and their companions is several times smaller than in the pair detected. Therefore, it was decided to double-check these space observations using telescopes on Earth. The observatories Lamos, MAGI, GMOS, ESI, X-Shooter, Pharos, and Hires provided their estimations of the radial velocity. These data were compared with the oscillation indicators, and mathematical calculations showed the presence of a companion star, a dormant black hole weighing about 10 times the mass of the Sun. The appearance of such an object in itself is a sensational event in the scientific community. It is important to note that this is the first black hole detected using data from Gaia. Next, remember that it is much more difficult to detect an inactive black hole, as it cannot be tracked down by the radiation of the radial light. The companion star in a typically long distance away is surrounded by particles in the stellar wind stream and has a sun-like structure. If this system also included planets, like most of the similar objects, it would be even more interesting for research. Scientists have suggested that the proximity of the system to our planet and the complexity of its detection indicate that there are significantly more dormant black holes than the X-ray objects. After the discovery of Gaia BH1, the team's attention was directed to the search for other similar objects. And just a few months later, at the beginning of 2023, the second most distant black hole from Earth was discovered, also located in the Milky Way. After decades of searching and untenable theories, Gaia discovered not one, but two objects in our galaxy. Karim El-Badri, the discoverer of new black holes, notes that major discoveries are still ahead of us. These objects probably have a completely different history of formation than the X-ray objects known to us. Their discovery suggests that we should adapt our theories about the evolution of binary star systems, since it is not clear how they're formed. Karim's publication in the monthly report on the Royal Astronomical Society, published on March 30, 2023, states the following. A red giant orbits a black hole. We report stereoscopic and photometric observations of a potential dormant black hole from Gaia TR3. The system, which we call Gaia BH2, has an orbital period twice as long as that of any previously studied black hole. It includes a red giant and a black companion with a mass of more than 8.9 of the Sun. Its orbit, like that of Gaia BH1, is too large to be formed as a result of the evolution of a common shell. Inactive binary systems of black holes significantly outnumber their bright counterparts, but the ways of their formation remain uncertain. Scientist Yvette Sendes, who worked on the discovery of Gaia BH2, explains, "This proximity of new black holes to the Earth is very interesting. It indicates that their number is greater than previously thought. The only issue in the matter is being able to detect them. The good news is that Gaia continues to collect data. It is expected that in 2025, the next report will be published. It will contain more information about dormant black holes and stars complementing them." ESA is looking forward to Gaia Data Release 4, the foundation of which will be 66 months of observation. It is expected to have even greater accuracy in the study of binary systems and the appearance of a larger number of candidates for the study of a new type of black holes. The survey of binary stars published in June 2022 surpassed all the research results of the last 2 centuries. The discoveries it was able to cause only spur the excitement of all space explorers. There are already a number of possible hidden black holes of a new type in the Gaia data, which are awaiting confirmation in further independent studies. A list of such exoplanets has also been published by ESA. Soon, we might just learn more about our galaxy and the laws that govern its existence.